Hey guys, it's Miss B. Sorry, I'm still getting over my cold a little bit, so this may be extremely monotone. I apologize. But today we're going to do some extra practice factoring trinomials where the a is greater than 1, and a is that leading coefficient in front of x squared, which I affectionately call earmuffs. So let's take a look at our very first example. All right, so our first example is 2x squared plus 11x plus 12. And as always, I'm always going to look for a GCF first. But since there's nothing that will go into 2x squared, 11x, and 12, I know that they don't have a common factor. And since that 2 in the front is larger than 1, I know, okay, this is going to be an earmuff. So I'm going to circle the first and last coefficients. Notice that I didn't circle the x squared, just the 2. And I'm going to multiply those to get 24. And let's just get our setup. So we're going to have 2 sets of parentheses. And that leading coefficient, which for us is a 2, is going to go in the first spot in each parenthesis. And then it's also going to go underneath. We're going to divide it out because I switched the problem when I multiplied by 2. So I have to undo that by eventually dividing by 2. So now I'm going to put my x's inside the parentheses. And now I'm trying to think what's going to multiply to be a 24, but also add to be the 11. So let's list out our factors on the side. So I've listed out all my factors of 24, and it multiplied to be a positive 24, which meant that they had the exact same sign, which also means that we're going to add up our factors. And since I'm adding to be a positive 11, I know it's going to be 2 positive signs inside there. So the pair that adds to be 11 is going to be the 3 and the 8. So now we're almost done, but I have to divide out by that 2 in the denominator. And I can only divide if it goes into both parts of the parenthesis. So the 2 goes into the 2x, but since it doesn't go into the 3, I'm going to leave that set of parentheses completely alone. The 2 can divide in evenly into both of those terms. So my final answer, that first parenthesis isn't going to change. It's going to stay 2x plus 3. But the second one becomes x plus 4 after I divide both of those terms by 2. And that right there is my answer. All right, let's try another one. Okay, so I have 3x squared plus 14x minus 5. And once again, no GCF for 3, 14, and 5. So I'm going to set up my earmuffs. I'm going to multiply the 3 and the negative 5, which is negative 15. So you want to make sure you put that sign with it so you don't forget. And I'm going to set up my parentheses. So remember that 3 goes into those leading coefficient into all 3 of those spots. First part of the parenthesis and underneath. Put your x's inside the parentheses only. And now I'm multiplying to be a negative 15, but I'm adding to be the 14. And if I'm multiplying to be a negative, it means I have to have different signs. So one of them is going to be a plus and one of them is going to be a minus. And now just keep in mind when we're adding, when we add a positive and a negative number, it's almost like you're thinking of subtraction. So let's list out our factors of 15 on the side. And now, like I said, this time, since it's multiplying to be a negative 15, we're thinking of them as subtracting to give us 14. So it's going to be the 1 and the 15. Now, the bigger number always gets the sign in the middle, and the middle sign is a plus. So the 15 should be the positive, and the 1 should be the negative. Now, I notice a lot of you like to put your signs and your factors on the side. So we can always kind of say, okay, it's multiplying to be a negative 15. Keep in mind that you have to know that the bigger number is going to get the positive because of that plus in the middle. So the smaller number would be the negative, and now you can sort of clearly see how this one adds to give you 14, and this one adds to give you 2. So last step is just to divide out, and the pair that has the factors of 3 for both terms is that first parenthesis. So if I divide both of those by 3, I'm going to get x plus 5, and then my second parenthesis stays the same, 3x minus 1, and there's our final answer. Okay, example number 3. 4x squared minus 20x plus 24. And as always, we're going to look for a GCF for 4, 20, and 24. And this time I noticed that 4 will go into all of those terms. So we do have a GCF this time. So I'm going to factor that out. So remember, the GCF goes in front of the parentheses, outside, and GCF only gets one set of parentheses because you're really just undoing the distributive property. So if I divide all of those terms by 4, I'm going to get an x squared minus 5x plus 6. And now if you notice, we're really just going to be factoring this right here. This is not earmuffs because that's a 1x squared, and that's what we wanted all along. So we don't have to do earmuffs on this one because the GCF took care of that leading coefficient. So as I set this up, the GCF of 4 is going to stay on the outside of the parentheses, but then I'm going to create two sets of parentheses so that I could factor the x squared minus 5x plus 6. And I need to add to be the negative 5 and multiply to be a positive 6. So since I'm multiplying to be positive 6, I know that they have the exact same sign. And then I look at the middle sign, and that tells me, okay, they're both going to be negative since it has to add to give me a negative 5. So my factors of 6 are either 1 and 6 or 2 and 3. And since it multiplied to be positive 6, I know I'm adding them to get 5, so it's going to be the 2 and the 3. A negative 2 plus a negative 3 gives me negative 5. And that right there is my final answer. So just keep in mind that just because you see a leading coefficient greater than 1 in the very beginning doesn't necessarily mean it will always be an earmuffs problem. Sometimes it's just greatest common factor. All right, so one more example and then we are done. All right, so this time we have 6x squared plus 7x plus 2. No GCF again because that 7 and the 2, those are prime numbers, so they won't have any common factors. And I circle my first and last coefficient, make my earmuffs and multiply, and I get a 12 or positive 12. I'm going to set up my parentheses. So that leading coefficient goes in the first spot and underneath, and then don't forget your x's inside your parentheses. Now I'm multiplying to be a positive 12, so that lets me know they have the same sign. And since I'm adding to be 7, that lets me positive 7, that lets me know that they're going to both be pluses. All right, so let's think of our factors of 12, which is going to be 1 and 12, 2 and 6, or 3 and 4. And the pair that adds to give me 7 is going to be 3 and 4. So now I have to divide that 6 in. But if you notice, 6 will not go in to both the 6x and the 3 evenly. It also won't go into the 6x and the positive 4 evenly. So I'm going to have to do something slightly different this time. Since the 6 doesn't go in completely, I can sort of break that down. 6 is 3 times 2. And the 3 will go into this first bubble evenly, and the 2 will go into the second bubble evenly. So that's what I'm going to do. I'm going to sort of split it up. So if I divide 6x plus 3 divided by the 3, I'm going to get 2x plus 1. And then if I divide the 6x plus 4 by 2, I'm going to get 3x plus 2. And that's my final answer. And to be honest, this is about as tricky as earmuffs can get when you have to just take that denominator and split it up into two smaller factors. If you can handle this, you can handle any of them. So just take a look at some of the things that I sent you guys on Delta Math because you have some practice problems that you can try on your own. Good luck, everybody.